Live. We're gonna get this party started here. Let's figure out where we were. So we got this working yesterday. There we go. Wait, did I remove the ranged character? I did. That's not what she's supposed to be doing. Oh yeah. I need to implement death animation and apply attack event. Sorry. There's our socket. Want this and then get. Wait, we want the get socket location. Get actor. And then actor transform. Oops. I don't want any delay. Okay. Then it's spawn actor from class. BP ice that spell. Oh. There we go. Yeah, it worked. Okay. What is the range? Where did I set the attack range? 600. Oh, okay. I don't actually know if 600 is enough. It might be too far away. Oh. Move directly towards. Set tag cooldown. Make noise. Move directly towards. I think we need a new Blackboard task. Receive event receive execute AI. Okie dokie. And then finish execute. Oh. Unreal Engine AI. It's not what I wanted. Behavior trees. Hmm. BP chase. Controlled pawn. Hmm. Interesting. Wait a second. Oh yeah. Huh. I don't I don't think I like this yet. Boom boom boom. Mm, move to target. Oh, wait. Still too close. Wait a second. Oh, that's the walk speed stuff. Yeah, it's this one here. Unreal Engine. Get. Location. Unreal Engine. Get closest location between two locations. How to get closest point between two. God damn it, I think I need good morning. How is it going? I should start learning, but I haven't had time for that yet. Sorry about the hold up there. Welcome. I'm a little bit late on that. I'm sorry. Good morning. How is UE5 go? How's it going with UE5? UE5's going good. I should start learning to do. UE5 can take a little bit to get used to. Looks like you're a much better game dev than I am. Your graphical music stuff looks cool. That's dope. Yeah, there we go. That's some like really low level shit. Thank you for the follow, by the way. So, is this like, it is ASM. Holy shit. So you're making music using ASM. That's so cool. So is this like, I guess this is the drawing. Cool. There we go. Hopefully I can see some of this. Last live yesterday, sweet. The UI's fun. At least it's fairly straightforward, fairly easy. All things considering. Like I want to make sure that I say this right. Like demo coding's like the like where you hack the code, like you're trying to get it really small, right? There was that FPS that was part of the demo scene, right? Like that crazy FPS that was like super tiny. He's 64K. Yeah, that's what it was. It was the super tiny games, right? Read from that page beginning. Oh, I was scrolling through. I wanted to see if I could find that. There was that one game that one team made that was like crazy. I think that was part of the demo scene, but I can't remember. Ooh, uplink. That was fun. The demo scene is an international computer arts subculture focused on producing demos. Self-contained, sometimes extremely small computer programs that produce audiovisual presentations. Oh, this wasn't the game version of it. The purpose of a demo is to show off programming, visual arts, and musical skills. Demos and other demo scene production, graphics, music, video game. Oh no, it is video games, yeah. Are shared at festivals known as demo parties, voted on by those who attend and released online. What was that like super what was it? Really small FPS. That's the one. This game. This was part of the demo scene, right? Or was it too big? Yeah, I guess it was too big. It's our last C64 demo. Made on 40-year-old home computer. Hey, it looks cool. This stuff's impressive. I've wanted to try my hand at it, but I can't produce music, so it's kind of a non-starter. It's really cool, though. I also don't do enough low-level programming. These vectors? Or is there another... I might be a bit confused. This is really cool. No math in that system, really? That's kind of surprising. Wait, if there's no math, how do you get things to spin? Like, don't you have to calculate where it's going next? How do you make the... Is it all like hard coded? I guess if you hard code it all, it's gonna be faster, right? And since it's just pre-recorded essentially, you can get away with everything being hard coded. Yeah, that makes sense. This is really cool. .68502 assembler. I've only done x86 and x64 assembler myself, and my x64 was pretty like nothing too big, and for the x86 stuff it was mostly just reading it. Never actually like sat down and wrote anything meaningful in assembly though. It's cool though. I need to figure out... I'm still very new to like vector math and stuff like that. So I gotta figure out distance between I want one sec. I want to figure out the let's see, vector math. I want to figure out the distance, the closest. So I want to find the middle. I want to, okay, wait. Let's see if I can describe this. Actually, you might know the answer to this. I was gonna go bug Zach about it, but yeah, you're here. You might have the answer. Yeah, the Commodore 64 is a pretty old system. I'm not surprised that it's not in megahertz. What was it? It was in the 64 was in the 80s, right? So here's what I want to do. We've got the player here. Yeah, 82. Yeah. It's a little bit before my time. And then we have the AI, ranged AI here. Right? Let's say that this is the attack range. Yeah, I've got to figure out. Okay, so I can take the rotation of this, right? We want to find essentially some point here. Yeah, so I want to, I guess we have to figure out like, oops. All right, rot. Right. So we want to essentially have this. We want to find a point here, a random location based off of this point here. Hold. Yeah, no worries. Just thinking. So I need to find. So if we take the location of the player. So let's do this. P equals. And then R equals ranged AI location. And we're going to assume that these are all vectors. Right? So if we take the ranged AI location, so we have, one sec. I'm guessing this is the math that I need. There's a function, the clin. Wait, what? Yeah, I'm just not familiar with this specific here. How do you use? It's however it is possible to. I think there's a simpler way to do this. if I'm being honest. This does seem cool, though. This would take me quite a while to go through with all the variable names and to like write out what each one does and stuff. We have to learn that. Well, what I was thinking, right, was if I take the player location and so we have the player location. So what I'm thinking is, because like essentially like this doesn't matter, right? The actual radius. And then where was I? Where is it? Here. Oh, does this have the algorithm I'm looking for then? Oh. Oh, okay. Square root of x times x plus y times y plus c times c. So wait. I would need to visualize this. So yeah, I need to learn what this is though. Wait, it's here, right? How did I want to draw a sphere with a center at 0, 0, pass, seeing the point. Maybe not this one. We could go here. But it can be used for anything. Yeah, but like can you explain exactly like what it's doing? Like what's the purpose of it? I'm unsure on that. Like I know that people, well, Declan math. See below, I am not able to use value with the basics. Is there another name for this? I'm gonna slap my popcorn. I'm using it to calculate the light source, but it can be used for anything. Scroll source to end before draw after calculating. Number of faces. Calculate rotation angle. Scroll to the end before drawing after calculating birds. It was there, yeah. I think. Calculate rotation angles. Calculate rotation matrix. Oh, you mean before this? Like this set here? Okay. Middle of the screen. This one here. Well, I can see it getting used, and I'm sure I could sit down and figure out exactly what's going on here. Which it seems, because it seems pretty straightforward. It's going to take me a little bit to read it, right? Oops. So, projected X. Float. If all right, V3Y V1. So projected X, projected Y. Yeah, I think this is more complicated than what I need, though. Because, like, oops. What I was thinking of doing was just doing, to do, R, forward vector. Forward. Plus player location. Location. Minus, with this here, minus 600. Maybe, or whatever, and see if that worked. I'm in 2D you can calculate the delta for x and y. Yeah, I guess I could do that, right? Well, okay, so like I could do get forward vector, get row. Then you need vector lengths for those deltas. Yeah. So I could do vector delta. Oops. Wait, what is this? No, because I don't think the rotate. No, the rotator is the rot. Wait a second. Oh, okay. Yeah, that's what I thought. Recombine pin. So wouldn't the delta of this be like there, right? And then so this is the absolute center, right? Between the two, I think. To do isn't quite what I want, but I need to find out where these. I guess this would also be forward vector. Loop back issues again? That's unsurprising. Yeah, blueprints are a bit fucky. It's just they're a bit faster to like lay something out really quickly. Hey Zach, you might have a better way of describing what I want to do. All right, so I've got my range, Zach. I've got my ranged AI, right? And I want to find a location. I want to find a point close-ish to the player within, say, 600 units. Right? So what I was thinking was if I took can you add grids? You mean like this kind of grid? Yeah. Wait, what if? Wait. I just had a thought, right? So if I took the player's location, the X, Y, the Z doesn't really matter, but we'll put it there anyways. And I have this, right? Would be like X equals, sorry, then this one here will be XYZ, right? We want the X plus 600 depending on where this is, essentially. And that will just give it, because we're just looking for the X and Y, really. Oops. We want to add, essentially all we want to do is add 600, roughly 600 units. Let's say, yeah, 600 units to the player's location. Add 600 units to the player location in the direction they're facing. Get random reachable point and radius should give you a valid location on the nav mesh. Yes, but yeah, I thought the calculation though would be I'm not good at, like, I don't know a whole lot of vector math. So I know pretty much no vector math. That's why I'm trying to figure out what I need to I need to figure out what I need to search so I can find the vector math to understand. Player X minus should I get in your ear? Oh, I was right. Okay, so that will tell me that will give me essentially this point though, right? Sure, Zach. Let's move to Smash no Jutsu. Oh wait, no, you're not in there. I'll see you in Morty's. In Vox, where we normally meet. Then use the Valkyrin XXYY. I wonder if there's a Valken. Get your result for vector length.
Alrighty. So
Zip.
you want to
Wait, so it'd be sorry.
right.
Yeah.
So let me get this straight. You want to get a random point within the radius of the player, but you kind of have this
No.
like profile.
I want to get so I want to set the target point here. And then I'm going to do a random in radius from here. Because when I do the random radius, right? It keeps giving me like right here.
Okay, so you want to essentially have that your Okay, stupid question. You
Well,
you take the distance.
let me show you what happens, and that might actually help, right? Give me a couple seconds there. Okay. So if I do this, get actor location, get random location reachable point, right?
Okay.
And I give it a radius of 600, right? Let's just
Yeah.
move some of this around here, move this up here. So this will give me that random location within a radius. Set value as vector. This also could be, oh wait, I already have that. There we go. Don't need that. There we go. Here. Right? I wonder if it's maybe just executing too many times.
You could also just get a random direction vector in a cone.
See, they just run straight to me before they start doing anything. Right? So I'd like them to like stop on the outskirts of me, like see, now they're working. They're a bit jank, but they're working nonetheless. Right?
Yeah, so to be honest, I'd just do this the lazy way. If you just get a random direction with a cone based on the look vector at the player, and then tell them to move a length proportional to the distance you want them to be away from you.
Well, I was thinking if we do something along the lines of what Proton Fig. By the way, you should drop them a follow. I think you might like their content.
You know, it takes me months to follow people. Yeah, I'll check them out.
Yeah, you should check them out. They do demo stuff, like old
Oh,
school demo
demo
stuff.
scene.
Yeah,
Yeah, that's fun stuff.
yeah. And they've got an idea that might also work, which is using what was it? It was the Veclin. I'm not familiar with it, but it has to do with like figuring out radiuses or something like that. And then we've got the, so if we have the X, this is, oh, I'm on. So they were suggesting x equals PLR x minus AI, sorry, x, right? But I think
Right.
that would just give me the absolute delta between them, right?
Okay.
Although I could loop over that, but that's an ON problem.
Well, to kind of simplify this down, you essentially want to tell the AI to go to a random point on an arc segment, right?
Well, okay. Let me actually just let's start a new one. We'll start this, right? Okay, so if the player is here, right?
Right.
And the AI is here.
Yeah.
I want to find a point here. I want to find this location.
Okay, now does that location need to be centered between the two actors? Or at any point on an arc between the two actors?
One sec. To find AI player. Right?
Right.
You got the results
So,
from vector length. Yeah.
because yeah, if you just take the distance between the two actors,
Well, no, because I don't want to find the absolute center.
right? So you just need to interpolate.
Well, so this distance, right? I want to find essentially 600 units away from the player in the direction of the AI. I know it's easy. I
Okay.
just don't know the math equation for it.
I mean, if you want to be really lazy, you just take the look at vector from the player's location to the AI,
Yeah, that's what I
and
was.
then you walk 600 centimeters.
Well, how would I figure out the? Wait, sorry, the forward vector, right?
So okay, so for a direction vector from one point to another, you need to get the. How are you with this category of algebra? Let me back up.
What result you need? Okay, okay. So I have so proton. I have the the vector location for this, and I have the vector location for this. I need to find the vector location for this, which could be 1,000 units here in this direction and 500 units in this direction.
So pseudo, there's a function that's just called a look at function.
Oh, there is?
Oh, yeah.
Oh, wait, not that one. Wait, is that this?
So that one is slightly overbuilt,
Okay.
but that's also what you'd want to Google.
Find look at rotation.
And yeah, you could step through a rotation and then just convert that to a direction vector if you wanted.
Oh, no, this is what I'm Googling, right?
Oh yeah, so
Coordinate. I need a coordinate. I'm just looking for the vector location in the world space for that. I
and
don't need a
you need
radius. No, I mean for Proton's question. The end result is I need a vector location, right? Because after I find the vector location, I'm going to pipe that into the random location at this point, right? And then I'll get a little yeah. That makes sense, right? I'm not slightly crazy. Only a little, right? Crazy on days that end in Y. So you said look at, right?
yeah. And I think there is there should be a function also just for getting a direction from 2 points. I don't remember the
Ooh.
name of the function off the top of my head, but
Unreal
yeah,
Engine
just
get direction.
but essentially you just take the two locations,
Yeah, it's just the percentage
subtract
of.
one from the other, and then that gives you the direction between the 2 points. And obviously the order of your operands determines which direction you're looking from.
How to use the new calculate direction node. Oh, there's a calculate direction node. Wait. So it's just some percentage of delta. Yes,
Now,
but I don't ever know what the percentage of delta is the other problem.
now if you want to be really, really fucking lazy here,
Which I do.
you can just lerp the two vectors.
What do you mean?
There's a vector lerp node.
Isn't that just for you can't code it? Well, I don't understand so I need to figure out also what the percentage is if I'm going to do based off percentages.
Well, so obviously, if you have a total distance, which is just going to be the length,
Wait,
the
so
distance between the two.
linearly one sec. Linearly based on alpha 100%, which is of A and So how does this one work? Linearly interpret between A and B based based off based on an alpha.
So if you feed the AI location into one and the player location into the other, and the alpha is 0.5, it will move to halfway between the two.
Then how do I find out what
Now, do you
percentage
want it to
six?
well, do you always want it to stand precisely 600 centimeters away?
No, I just need it to be at least 600 centimeters or less.
And do you want it behavior-wise to essentially move to this location in one go, or do you want it to make multiple tries?
I guess I could make multiple tries. I just would prefer if it tried it all at once.
Okay, so you just want to walk directly from wherever it is once it hits this blackboard task, and you want it to walk to a point that's precisely 600 centimeters away.
Yes, I want to be able to put in a precise number of a distance away.
Okay, so let's break this into steps. Step one, let's just get our direction vector. So, location of one, location of the other, subtract one from the other.
Well, the rotation should be okay if we just get forward vector.
Oh, we don't need the forward vector. Forward vector isn't involved.
Oh, sorry, we're getting. So
Just get
the
the locations. Just the locations.
Okay. Okay, we have the locations.
And so your direction is when you take the location of one and you subtract it from the other.
Yeah. Okay.
And so now if you want to essentially move along that direction, you just multiply it by the distance you want to move.
Oops.
So you should be able to just multiply a vector by a float.
No, I know, but I meant to do this.
Ah, okay.
Okay. Which location
And
is the
so
base, though, for this?
off the top of my head, I can't remember.
I feel like
it's
it's going to be this way, is what I'm
yeah.
probably looking for.
And then obviously since this is going to be a kind of local movement, you then want to add the location, essentially, of where you're starting from.
Oh, okay. And then. Oh, from where I'm starting from? So I want to base this off of the start location of the
So once again, though,
player.
that is not a location. That is a forward vector. You do not want the forward
Oh,
vector.
right. Oh, right. Wait. Right. Get actor location.
Yep.
There.
All right, and so then you want to add the location of essentially where the line starts from.
Okay.
So we'll likely need to fiddle these around.
Oh yeah, this one here is the one that I wanted to add.
Yep.
Let's do this, and then we can bring this one up here and this one here. If I move this into C++, I think that Proton will also be of more help.
Yeah, this spaghetti obfuscates the clean, simple, nice-looking
Oh
equations.
yeah. We're gonna move this into C++ very shortly here. And then the second I move this into C++, I think that Proton will understand more of what's going on.
Yeah, and
I feel bad that they have to look at this. There we go.
yeah.
Ugh.
I mean, okay. Personally, I feel bad whenever I'm looking at any kind of vector math that isn't expressed in MATLAB. Like,
Okay, this
MATLAB sucks,
I
but
think this makes sense. Here, Proton, I'll write it out. I think that you probably understand it. Yeah, I'm looking it in at it mouth open. Okay, so what we've got is this is the so this is our player location and this is our AI location. We subtract them from each other to get the delta. After we have the delta, we add 600 to it. No, or we multiply it by 600. Then we add the actor location to the output of that, and then we pump it into don't worry about this. I think this might work. I don't understand how it works, but I think it works. Let's see if it worked. It doesn't work. Either
you
that.
might want make the distance significantly longer.
I think if I make the distance too long, it's not. I'll have to adjust it.
And also, let's think through our steps here. Kind of bring back up that diagram. So what we want to do is we want to find the point that's essentially 600 feet. You essentially for your line, put the arrowhead on the line that goes from the player to the location. That is essentially what we're doing.
Yeah.
We're going from the player, get the look at from the player to the AI, traverse from the player location to that point. And that essentially tells us where we want to go.
Yeah. There we go. So if we write this out, this is AI X Y minus P X Y
Also
oops.
have a Stack Overflow link.
Oh, you can post in chat. Times 600 plus P X Y. X2 minus X1. Normalizing means to scale a vector so that its length is 1.
And yeah, there's just a normalized node in Unreal, so you don't need to do the normalization yourself.
Oh, so is that the part that we didn't do?
We did not normalize, no.
Isn't that just intersection? Yes, that actually describes what I want to do quite well. Wait, where do we normalize?
So
Right
normalize
here?
before multiplying, yeah. All right, then also for our debug steps, let's skip that random point in radius node.
Yeah, that's a good idea.
And something you can do, later on if you want, is there is a random direction in cone node. So if you want to kind of randomize it a little bit into kind of a point along an arc between them, that gives you your option there.
Why? Why are you mean?
Now in
I gotta
the
fix that
black,
rotation thing at some point.
oh yeah, that's a little bit fucky.
Yeah, a little bit fucky wucky. But I think I have a solution to that, and it will fix the problem anyways.
Oh, and for this ranged enemy, what is our user story for this AI's behavior?
AI runs to once player is in set range, AI runs X distance. Sorry, AI runs to X distance of player and starts casting at them.
Okay.
Yeah, that's everything. That's all the logic we want is essentially the AI runs towards the player, stops when they're X distance away, and starts casting.
All right. Are these like
Or
is that
roughly X distance away.
okay? Is that casting speed what you're sort of aiming for here? That kind of
No, but I'll tune that down.
okay.
Yeah. I haven't tuned it yet because it's easier to debug this way.
All right. And is there anything in your blackboard that would cause it to run to a different location? Like
I
is there
thought that
anything that
I
might cause it
changed it.
to
Let's
okay.
double check. Wait, can you move to a position in range? Do you think this might work?
Well, what does that tooltip say?
Moves the AI pawn towards a specified actor or location in a straight line without regarding any navigation system. Oh, God damn it. I was hoping to use this one and then like acceptable, like moves the AI pawn towards a specified actor location. Blackboard entity using navigation system.
All right. And is that acceptable radius for the search radius or the destination radius?
It's supposed to be the acceptance radius of like between the location and the AI. Like this reads as if it should just work.
All right, let me pull up the docs on that.
Fixed. Okay, so acceptable radius, fixed distance added to threshold between AI and goal location in distance reach test. So what if I make this like say 300 and then pin this one up instead? If this just works, I'm going to be so annoyed with myself.
Well, makes it educational.
Yeah. I also just realized something that I totally didn't do.
What?
Set this move to up correctly. Mm. Then we're gonna need a move to. Wait. I think that's right. Yeah, I think this. Let's see if this works. Why? Why does it keep doing this? It's always off by just a little bit. Mm,
Off based on where it moves or where it shoots?
where it moves.
Do you have
I want
have
it
you played around with the AI debug tools? You know, that whole separate window that then enables your on-screen visualizations?
yes, but we're not using enough of it.
All right, so it won't give you the debug objects that you want. Okay.
No, it won't give me because I'm not using the QS whatever it is. Unreal Engine AI. What was it? It was go to behavior trees. No. Environment query system. The EQS system. Because that like lays down where you're targeting.
Right. Yeah.
And because
Okay. So,
I'm not using that, we won't get like the
so you won't have the sensorium to visualize.
yeah. I'm also not actually using senses at all.
Yeah.
So,
You could be using the state tree system if you want even less documentation.
well, yeah, like that was something that I considered.
It it's a
It looks
it is
really
so
cool.
close. It is so close to being ergonomic.
Yeah, it looks really nice. I want to play with it, but it's just so not documented. Oh no, that's the mass. There it is, stake trees.
Yep.
This looks so cool and just not super useful because they
It
didn't
the
document it fully.
Yeah, it is very much documented by someone who has never had to actually teach it to someone else.
Yeah, I can totally see that. You have to
So like
essentially you have to know how to use it before you can read the documentation and know how to use it. You
yeah,
have to have a
you have
certain level of understanding first that I do not
yeah, you
possess at the moment.
and so you have to read the entire thing. You have to
I
like
have an
guess like wait,
idea.
okay, hit me.
I have an idea that will help us with debugging.
Why don't you just put a draw debug node in there and
Oh
draw
yeah,
the
yeah, that's
debug sphere?
debug. This is a good idea. Don't let anybody ever tell you you don't have those.
And it might also be a matter of needing kind of like some intermediate math because
Maybe.
obviously moving just a fixed 600 centimeters down that path
Right now, I don't
won't.
even care if they start attacking me correctly. I just want to see if they. Wow, apparently it didn't even hit that. No wonder it's not been working.
Yeah.
What the actual fuck?
Might need some breakpoints here.
Well, we can troubleshoot this one. Uh,
Also, is that extra move 2 getting in the way?
we'll move to. This just sets it. This actually does the move.
Okay, so that's just setting your
Yeah, either that or maybe I'm using the like I've got this set up wrong.
Well, wait, if your attack radius is 600 centimeters,
Hmm.
then in what scenario is it moving to an attack location? At what distance is it doing that move?
1,000. So it enters here at 1,000 when it's
Okay.
1,000 units away from the player. And
All
then
right.
here it's supposed to start attacking. And then here I've just set it to acceptance radius of 300, or we should say 10, since it's supposed to move to our set location, right?
Yeah, yeah. So to the move to. All right.
As I move to location. And okay, save. All right, let's do this. Play. Well, I figured out why it's not working.
Why?
I think AI controller is the melee controller.
You know, that would probably do it.
It might this might fix the problem.
Yeah. This, in the very least, this will give us a brand new set of problems to deal with.
Yeah, at the very least. Well, it did give us a new set of problems to work with. It's
Yeah,
doing
it
the
essentially.
thing.
Yeah, yeah. Well, from the looks of it, it ran to a point on the opposite side from the player.
Yeah.
Now, did it actually draw that debug sphere long enough for us to see it?
No. Apparently I made that too short. 1 second is too short.
Yeah. And obviously, you can kind of essentially take your intermediate products from that location calculation. If you want to draw a debug arrow to verify where it's going from and what direction it's facing in, so you can print all of that, or rather draw all of it.
There it is. So it's going in the wrong direction, which
So yeah,
means that these probably need to be flipped.
well, what I would recommend doing is drawing a debug arrow, because that lets you set a start and end location.
Fine, I'll draw a debug arrow. Jeeves.
Well, this means that you can essentially take, so the start is going to be what we're adding to the direction vector.
Why did this not take?
Because you need to change the luminosity, the other slider.
Yeah, well, you know what? Oh, wait.
And so what yeah, have that as the end, and then up the size and thickness and what have you.
Duration of 5. Arrow size of 12. I think the thickness should be fine. Because I think that's like the default thickness, right? If you don't give it a value. Do, 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 do. That worked. That worked. I figured it out. Now we just have to fix the rotation. Between you and Proton, we got this down.
Yeah. Yeah, that worked pretty well.
Yeah.
Once we actually put the right AI on there.
Then this. Oh, is this the cone check that you were talking about?
I was actually talking. There's an in blueprints, just a standard random in cone.
Hmm. Then we just add
I
a
like to use
cooldown
it.
to it.
Yeah. I
And
like
then
to use the random in cone when I'm doing just fucky bouncy bullets.
that makes sense. Ranged enemy. I don't want 5. Let's do 2.5. Let's leave. Say 5.
How many of these ranged enemies, like per group, are you thinking?
Probably law. Oh, I don't know. Maybe up to 20, 30,
Okay.
50. There'll probably be
All right.
about
And it's
100 every map.
all right. And so is the goal like bullet hell?
No. I do need to increase the it's the movement that's causing the problem. Why is the attack so constant here?
So read the text on the cooldown. Lock for 10 seconds after execution and return failed.
Or
Oh, or sorry, your text size is kind of small.
no,
So our
so a decorator node that is based on its condition on whether a cooldown timer has expired. Cooldown timer is 10 seconds.
no, that is and return failed, not or return failed.
Oh yeah, here, but like this actually does prevent them from just spamming it usually. Because I used it
Okay.
on the melee and it worked. 2.5 ended up being the correct one for
All right.
melee. I did tune it a little bit, but I think that's what I think it. So what we can do is we can come up here and we can do. We've got the range character, right? And if we
Right.
come over here, we can. They should be down
Yeah,
here
bait
somewhere.
them in and see what's.
Oh, okay. So I know what's wrong now. So they were over here executing, but they
Right.
were still firing, so they never stopped firing.
Ah. Yeah, that'd do it.
So I did the ranged AI dirty. Hey, I know why I did. Disable movement.
Oh, yeah.
Character movement mode.
Now, will you have you'll have attack animations for the ranged attack. You'll have some.
Sweet.
Yeah, I assume you'll have notify set up eventually, so you can enter and exit at reasonable points.
Already did.
Okay.
Yeah. With this one, I think that it's okay for them to walk up and like I essentially have them pause while they're actually
Right.
firing the bolt, and then they can move again. So they
Okay.
have the fastest movement thing. Set action. Set. No, what was it? Action. Enum. There we go. Back to idle. Dun 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 dun. Dun 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 dun. Yay, it worked.
Yeah, it looks like it's having some issues though.
Yeah, that's fine. We just there's a little bit of it wants to be exactly X distance away from the player at all times. So if I walk towards it, it runs away.
Which has some potential mechanically speaking.
Yeah, but it also follows me exactly. What I was gonna do was so this works. We're good on this. We can delete this. First things first, we want to get a random location within, say, 10. Right? And then we'll put this through the debugger. We'll move this one up here too.
No.
And I think we're ready to move this into C++.
Which should be significantly easier to deal with.
Oh my god, this is so painful. Or should I leave it for debug purposes in blueprints for now?
It depends on
How
what all
does
you want to do to finesse this.
how well does the draw debug arrow thing work in C++? Because I've had problems with
It,
some of these in the past.
it's not nearly as convenient in C++.
Okay. That's what I was thinking because it was pretty inconvenient when I was trying to do that type of stuff earlier.
It okay, this I despise global objects. I especially despise having to get a global object just to call what should be a function that's not associated with anything.
Are you talking about like the get world stuff?
Yeah.
Yeah. Yeah, it is kind of annoying. Okay, so I want this to come down, this to go here. There we go.
Oh, shit, some of the Unity projects that I've been on, it having to declare a static namespace just to have static functions because they obviously have to belong to something, but the namespace doesn't allow any kind of like actual module based mangling that'd be useful.
That sounds like Unity.
Yeah.
You leave Unity out here. Unity, our Lord and Savior.
The problem, all the jobs are for Unity. It pays, and if you fail as a Unity dev, oh well, that sucks. Now you gotta go do enterprise stuff because it's all C sharp.
Yeah, that's kind of true.
You have you seen the enterprise FizzBuzz repo?
Yes. Doesn't it not
Yeah.
actually do FizzBuzz though? Isn't that the joke though?
Yeah. It's
I
it's a
am
horse designed
so
by committee.
yeah, I'm 100% looking forward to moving this into C++ so bad.
So now it just becomes a question of what do you want to do to parameterize this? What do you want to do to add character to this movement?
What do you mean?
So
We essentially have
l-
all of the parts.
you have the parts, but you can get little kind of expressive bits of behavior just out of how you do your math.
Well,
So aspects like AI aggression for how quickly they step up or how aggressively they'll pursue a better angle to attack from, things like that often end up being just down to shitty little bits of math.
I think that eventually I have to add a sight back to this one at least.
Like a line of sight verification.
Yeah.
And you have some strafe behavior already, right? For circling.
No.
Oh, you don't?
God, no.
Okay. You at least have strafe animations for your locomotion.
No. They're not worth implementing right now. The reason why they're not worth implementing right now is because they have to get thrown out.
Ah, true. If
Yeah.
you're redoing your walk cycles and stuff like that. But something to consider is like if you look at patterns of aggression in say the Arkham Asylum games, you'll essentially find that the differences in what we perceive as enemy aggression effectively just comes into how they crowd without actually attacking, and specifically how readily they crowd into the viewport. They do some mathy fuckery where rather than just basing it on a real world location, they look at the actor's location in screen space and step up based on that in order to push them into frame.
I'm think that's more advanced than what we want to deal with for this.
But there'll probably be some simpler options that you can consider. Like, if their shot is obstructed, will they aggressively move to a new location, or is there a greater chance of them waiting for an open shot?
No, I'm
Are
just gonna
they?
have them move to a new location
Uh,
until they have a line of sight.
it's like 3 lines of code, a little bit of random math.
Yeah, I'm just gonna have them move to a new location.
Yeah, but is that as fun as having some that are perhaps patient and then they just headshot you?
No, because all of the projectiles move at the same speed. So the
They don't
pain in
have to.
the well, it's just easier, and we have a time. That's just a proof of concept. Can we make a
Yeah,
game?
but all it takes to change that is you have a wait time variable for how long it stays still without repositioning. That changes your projectile velocity. It's like two
I'm
variables.
I'm not saying you're wrong. I'm saying that largely at this point it's not a problem that I want to solve and add extra complexity because it's more important to get the game to a certain state before I
Yeah.
start adding extra stuff.
And you're not sure what parts aren't fun yet. That's always
Yes.
the independent of making the game fun is learning what parts aren't fun.
Yeah. Also, I don't know how this is going to feel yet. Like that rotation issue is a problem. Where they just random and they're obviously not. I've got to figure out how to get them to hmm. See, this doesn't work.
So there are a
So,
couple easy ways you can change it though.
yeah, that involved the forward vector, right? So, what I'm thinking, bear with me. Let me get back out my math page of drawing.
I'm disappointed that you're not just using Epic Pen directly,
I don't have Epic Pen installed, and I got really mad at it the first time I used it. I haven't
it
I haven't I haven't gone back to
it's
it.
a weird intersection of useful and shitty.
Yeah, that explains Epic Pen very well.
Like part of me is almost tempted to be egotistical enough to say, I bet I could do that better.
I bet that you for the base functionality, I bet you probably could, because I think it's a bit over engineered for some of the things that we do with it.
Well, and simply the fact that none of it is any kind of standardized interface, it feels like just a little bit too much jank.
Yeah, possibly. So okay, so for the targeting system for the casting,
Yeah.
we're gonna essentially use the same kind of pattern, right? So we have the player,
Yeah.
right? And let's say the player is moving in this direction here, right?
Yep.
We have the AI here.
Yep.
Currently, the AI will cast to the player. Location. But if the player is moving in like 2 frames, the player will no longer be hit. Make sense?
Yep.
So what I got to do is figure out this location and cast there.
Yeah. So you just take the forward vector and your velocity.
And add them together. Right?
So yeah, you essentially you
FV
take your
plus velocity, right?
now your velocity, if it's just simply expressed as a vector, kind of just gives you both direction and magnitude already. So the question here,
Wait, can you repeat
right?
that?
So if you have both direction and magnitude, that gives you your velocity here. If we're talking the difference between like speed and velocity, one has direction, the other doesn't.
Yeah.
So the important question here
Wait. Magnitude?
is, at
I didn't
what
spell that right.
point does this kind of aim anticipation not feel fun? Because you can take your forward vector and you can take your velocity and you can just perfectly say, at this exact point in time, we need to aim here.
Yeah.
You can also then take that, and that's where like the random vector and cone comes in. If you want to add 5 to 10 degrees of variance,
Mm-hmm.
and then you just scale the size of that cone based on the distance from the player, so that way it's dynamic. That's just easy math. The other question you want to do is, at what point in the attack does the AI commit to the attack direction?
There's only one frame essentially.
So over the course of the animation, right? You have your wind up, and then at a certain point it casts, right?
Yeah.
So a trick for that conversation of the perception of fairness, or the verisimilitude
Right now
for
I want it
this.
to be an aimbot.
Okay, so you just want pure aimbot.
Pretty much. But
Okay.
okay, so I want its aim for when it casts to be absolutely perfect. Actually, I think it is perfect. The problem is that the object's too slow. So the object's a bit too slow. So I want to aim to where the player is going.
Okay. So you want to keep it slow, but anticipate on your aim.
Yeah, so we got to get the speed of this.
Right, because now that's also kind of a question, because if you know the velocity of your projectile, you can then just essentially project forward in time. That obviously won't compensate for if the player just suddenly jukes.
That's exactly what we want to do.
Okay, so you do want a little bit of bullet hell to it.
Oh yeah, totally. So like the AI is sitting here, players sitting here. We want it to shoot out where the player exactly where the player is going. Once it's been fired, the player gets the option to choose to change direction. Right. So
Okay.
yeah, bullet hell, but we're not going to have that we're not going to have that much firing going on in a single area. And
Yeah.
if you are, then you're just really unlucky and get good scrub. And then
Yeah.
this is going to
Yeah.
be
Fair.
me sitting here raging, pseudo rage because bad.
Hey, fair. Now, in terms of parameterizing your math here, right? You can essentially accommodate for player speed and projectile speed at the same point in your equation.
Well,
Because
we're
that's just
building a triangle at this point, right?
pretty much, yeah.
Yeah. So we have this, this. We want to find this, right? So we can find, I guess this, the, I guess this would always be a 90-degree angle. No, it wouldn't. We don't know this.
So yeah, that angle will depend on the distance of that line between the player and the AI. So essentially, the longer that x is, the difference for that angle for between x and y, or well, essentially the longer x is, the longer y is.
Yeah.
Right? Because if you have your speed per second, your velocity of your projectile, and then you have the distance, then you can essentially just divide one by the other and kind of get the total travel time for that straight line and use that to anticipate.
Okay, so let's see here. So this here, right? Will,
Right.
if I'm not mistaken, this will be the forward vector,
Yep.
right? Plus the velocity.
So you're going to multiply by the velocity.
Times the
It
velocity.
Yeah. Well, if you just do the length of your velocity vector, that gives you your scalar. But
What?
okay, so velocity is a vector, direction and magnitude. If you want to
Yeah.
just get it for easy multiplication, you take the length of that velocity vector to get it just a scalar.
Okay.
Then you can use that to essentially scale the direction.
Okay, we'll come back to that. For now, let's just write out the base of the equation.
All right.
So it's forward vector times the velocity, which is the character's current walk speed, right?
Yep.
Then, and this will give us this location here. What should we'll say this NP equals NP L, new player location, right?
Yep.
Then how do we figure out? But now we have to adjust for this. Who
Yep.
dis?
Oh, hey,
Howdy.
O'Don.
Hey, how's it going?
So,
It goes.
Right on.
so how do
We
we adjust for
are.
this?
So remember how we got our direction vector for our first bit of math?
Yeah, that was
Oh, I just wanted to pop in real fast before I head off to bed, but
so. All right. Well,
Yeah.
have a good sleep, man. It was good chatting with you today.
Yeah, I have to ask, is it like, is the joke on your name, is it like the other, like Chen?
It. Have you watched Brooklyn Nine-Nine?
No.
You should. It's mildly hilarious. But yeah,
Okay.
99% of people just end up pronouncing it Zetchen.
Chen.
And then there's the occasional Turkish person who think it's an SH, but yeah,
Tell me the
as for the
name of it one more time.
Zetchen.
No. The name of the show.
Brooklyn
Brooklyn
Nine-Nine.
Nine-Nine.
Yeah, this is like my bedtime because I'm usually up at 5 in the morning opening clinic.
Ah, fun.
Okay. Well, I will save that to my watch later. Sold. Well,
Alrighty.
on that note, y'all have a good one. We'll catch you later.
Yeah. Yep. You
Yeah,
too.
you
Have a
too.
good night.
Good night.
Oh. I think I understand the math now. So we need to figure out we need to use this here math on this, right?
So it can actually be a little bit simpler, right? So the spells, they just go forward until they stop. They're not aimed at a point on the ground, right?
Correct.
So if we have the location where we're going to estimate that the player will be, all you need to do is get the direction from the AI to that new location. And so that's that same, you just subtract one from the other and that gives you the direction.
Well, no, because we have an account, like we can account this for the speed of the character,
Right.
but that doesn't account for the speed of the bolt.
Right. So you just need to essentially then multiply it by something that's going to be proportionate to the speed of the bolt.
Multiply this one.
Yeah. You essentially just aim further ahead to account for how slow it is.
What would that look like, math wise?
So let's say the distance between them is 10 meters, right? And
Like
then you're
between here and here, right?
let's start with first just between the player and the AI. So the length of X, let's say that the length of X is 10 meters. And for the velocity of our projectile, if it's covering, just a flat, well, say 1 meter per second,
Yeah.
so it would take 10 seconds to travel.
Mm-hmm.
You then just need to take the velocity, your speed, your movement per second of the player, and multiply it by the number of seconds.
Give me a second here. I don't quite get it yet.
So if your player moves 2 meters per second,
Okay, so 2 ms. Yeah.
and the player is 10 meters away, and
Oops.
your projectile moves 1 meter per second. So then you know that for how far forward along that player's forward vector needs to essentially match the time it takes to traverse. So if it's going to take 10 seconds to get there, and you know that they are going to be essentially 10 seconds farther forward. So it's going to be
One sec. Proton. Right now we've got the ice bolt firing to the correct location. But the issue now is that the bolt fires to the current player location, and we're trying to adjust the bolt to fire to where the player is going instead of where they currently are. So if this is the current location of the player, we need to figure out where the new player location is going to be to fire the bolt to. Does that make sense?
so what I want you to think about here, right?
Mm-hmm.
The length of X, if we imagine that we rotate X around the AI, it's
Like
going to
this?
obviously give us an arc. Yeah. So
this would become X plus Y, though.
yeah, a little bit of, classic math here for that hypotenuse. So when you think about it, though, so your player is going to move from the player location to the new player location. They're going to move there over time. So for our numbers, in the 10 seconds that it'll take the projectile to move from AI to player. Yeah, for these round
anticipation.
numbers. So in those 10 seconds, the player will move 20 meters forward.
Yeah.
As the player speed.
So here
meters
we'll
per
say Y equals 20.
So, yeah.
Okay, and then what was our X going to be? 10?
Yep. Obviously, the triangle isn't to scale.
Yes, it's fine.
Yeah. And then for our hypotenuse, essentially for calculating where they're going to be for that new location, the length of that, and this is kind of where you have the element of finesse for essentially how accurate you want them to be with this anticipation. Because obviously, if you just rotate X, that's going to be an arc, and there's going to be a length difference between that rotated X and where that actual new player location will be. So you essentially have to say that the slower the projectile is, the farther forward you need to aim in order to compensate for that distance. You can kind of finesse that a little bit, so we can just get these initial pieces together, and at short distances, you won't really be able to tell the inaccuracy.
Also, I want to speed it up. So we might be able to solve some of those problems just by speeding it up.
Yeah. Speeding it up will kind of put you in a position where it's just rounding errors.
Yeah, I'm going to speed it up and probably make the collision box bigger.
Oh, yeah. That will kind of solve a huge chunk of the math then.
Yeah. So we can make it a little less accurate, but still have it feel like it's fucking homing.
I mean, if you want it to home, just enable homing.
No, I don't want it to home. I just want it to feel like it's homing.
Okay. So a trick with the homing is you can set the homing acceleration to be this minuscule value, and it will essentially give you the exact kind of aim anticipation that you're shooting for here.
Oh, you can do that?
It
Let's
won't
play
feel
with you know what? Let's play with that right now.
Yeah, so so ironically, I was just earlier today playing with a homing projectile with actually just with chaos destruction in this case, but yeah, for your ice lance, for your projectile movement, there is homing boolean, and then you have a target component to home towards, and just some variables you can set.
Huh.
And so yeah, what I would do is just on your on play, I would essentially just have a
Wouldn't it be on spawn?
so your on begin play is the equivalent of
Oh,
your
right.
on your on spawn.
Oh, I already started this. Okay.
Yep. So yeah, then just down here, drag out a reference to your movement component. And then essentially just pull off and type in homing.
Set target component?
Yep. So for that, just, well, what part of the player do you want to home towards? For that character object, you can get, like, say, a root component. If you just want something with, just your root transform.
Get player pawn, I guess? Would that be right? No.
So pay attention to what it's saying for that cast, and then getting your root component, and then there's friction going between actors and components. That's kind of frustrating, but
Let's see how well this works.
now you'll also want to have a default value for your homing acceleration magnitude. I don't
Well,
recall what it is by default.
We're about to find out. It's not very good. It might be 0.
Yeah.
Class defaults. Class.
Oh, you'll want to select the component again.
You know, that might work.
Yeah, I hear it's useful.
Yeah, here we
Yeah,
go.
yeah, that.
We're just gonna play with things until they work. Play.
That's the fun way to do it.
Watch this. Hey, that works. Is there any way to have it do a rotation on that?
Yeah, there should be a checkbox for changing for the projectile rotation. Yeah, interp rotation.
Because that actually works perfectly right there. We figured out exactly how to do it, and it was a checkbox.
Or is it? Let me look at my own blueprint. I might.
You know what it is? I bet it's because it's all it looks fucky, but this might actually just work. This just kind of works.
But yeah, just that little bit of homing, like not enough to actually feel like you're getting chased, but
It's not enough. It's too weak. We're gonna double it and see. Double it and give it to somebody else. Oh, that feels better. Oh god, it's hard to it's actually hard to dodge a little bit. I want the homing to be a bit stronger. Actually, let's speed it up because it's still too slow.
oh, it's rotation follows velocity. That's the checkbox you want.
Rotation follows velocity.
Yep, just use a search box.
Do we need lerp this rotation?
I don't think so.
That works. Perfect. Thank you. Okay,
And
so
now
1000's still too slow. Sorry.
If you want something that's fun, you can throw in a timeline component to essentially fire off to change your homing velocity over time. So you can so you can do things like you can make your projectile essentially like good at homing at first and then later bad, or vice versa.
Let's do 1500. Did I make that too big? I did. Sorry. I think that's more than what we really want right now.
And obviously, you can also, for your on begin play, you can feed in randomized values. So essentially, each projectile spawns with a slightly different speed.
Hmm. I'm gonna need to do it. But for a different reason.
Okay.
I
What are you thinking?
I don't want them to be homing like this.
So, so are you thinking of just trailing off your homing magnitude over the lifetime?
Yeah, I think that's what we're gonna have to do.
So yeah, for that
Yeah.
you have the option of either A, just doing it on the projectile's tick, since it has a relatively short lifetime. So
Yeah.
it's not like it's going to take a bunch. Or you have a timeline component that gets played on begin play, but that's effectively identical to your tick.
Hmm.
Yeah, I'd just do it on tick for now, and if it ends up being a performance issue later, then just optimize it out.
No, I think timeline's gonna be more reliable. Like straight up, I just think that it's gonna be like actually more reliable.
Yeah, fair.
Because then because it accounts for like the time delta and stuff like that.
Yeah. And you can then also do a float track on your timeline if you want to have, nonlinear interpolation of the value.
Yeah. Well, actually, what I do, actually, there might be a different way of doing this. I have an idea, and this
All
one,
right.
this one actually should be fairly easy. Okay, so here's my idea now that we've got anticipation working. Anticipation works well enough at this point. Okay, so we
Oh shit.
have
You could just do a delay to turn the homing off.
no, no, but essentially that's what we're gonna do. So we've got the projectile, or sorry, we've got the spawn location.
Yep.
Spawn location. We have the player location, right? And then
Yep.
if the projectile passes the player, so let's say the projectile here,
Yep.
we'll say PJL is past the player, we turn off homing altogether.
Yeah. And so you can actually just finesse that with a pretty easy dot product.
One sec.
Yep.
Sorry. Okay. So what I was thinking was we can use this math to turn it off. right? Because we can say that if you're within once it's within that range, we
Yep.
don't need homing anymore. We just turn it off.
That's an easy way to do it.
Yeah.
And so, yeah, that's just you can get a distance between two actors easily enough.
Oh yeah. Yeah, it's just gonna be Icelance here, begin play, homing, do. We're gonna come down here. We're going to override the tick. And then on tick, we want to distance. I thought they had a actual distance between two locations.
Oh, there is. You just don't need an execute plugged into it. It's part of the back tree.
One sec. Hey, we got it.
Yep.
Is less than. Oh, wait, no, this wouldn't work.
Why not?
Actually, no, this actually might work. Less than 20. Projectile component set homing.
Yep.
Homing. Actually, we don't need a branch for this.
That isn't an invert.
Oh, yeah, that's not an invert. Is there an invert?
So there is a not rather than a not equals. So the not Boolean.
Oh, there it is. Thanks. There we go. Save, compile. Yeah, because the player is always going to be fired upon. I don't like that. Just because of that like weird fucking weirdness.
Well, if you want, so if you take essentially the dot product between the line between the projectile and the player, and then the projectile's forward vector, that will give you a scalar bound between -1 and +1, which you can essentially use to tell when the projectile has passed the player, because that will essentially change your value for your dot product if you just take the absolute of the dot product.
What's the dot product?
It's the degree to which the two vectors face in the same direction.
One sec.
So if they're perpendicular, the dot product is 0, and if they're parallel, the dot product is 1.
Oops, that's not what I wanted. Note to variable. Spawn location. Wait, do I need the spawn location for this?
So you can use it.
But would
I
I
see
need
what
it?
you're doing, and it makes sense.
But you said there's an easier way, right?
It okay. So this might be something you need to draw to visualize, but when the projectile is essentially before the projectile passes the character, the dot product the the forward vector for the projectile, and then the look at vector from the projectile to the player. The dot product, the difference there
Wait,
is
wait,
going to
wait.
be relatively small.
The look at vector, right?
Yeah, essentially the if to draw a vector pointing from one to the other.
Yeah, the look at vector. Um, dot product, right?
Yep.
To the player location?
Yeah. So a way that you can think of this is so the homing is trying to bring that dot product to 1. The
Yeah.
dot product is 0 when they're perpendicular, 1 when they're parallel. So the homing component is trying to bring that to 1.
Mm-hmm.
So as it diverges away from 1, you can essentially just hit the switch and tell it to stop homing. Now that's going to happen in 2 scenarios. That's going to happen for 1 when it's just fired off into the fuck all wilds, and 2, it's going to happen when the projectile is past the player. If it misses and goes past them, that dot product is going to be
Okay, so
near to 0.
wait. Do I have access to a dot product? Yes, between two vectors, right?
Yep.
So it would be dot product here.
So dot
Does it
product
matter
is
which
for
order?
doesn't matter which order. Now the important thing here, dot product is for directions, not locations.
So I need the forward vector, right?
Yeah, you need the forward vector of the projectile.
Yeah. One sec.
Yep.
Get. Oh, I know. Get forward vector. That's not what I wanted. Ah. Okay. And that one
All
goes
right.
here. This one goes here.
No. What you want is the direction vector from the projectile to the player. So remember when we took the one location and subtracted the other location?
Yeah. So that would be minus that, right?
But you'll want the location of the projectile into that minus, not the forward.
Right. Get location.
It'd just be the get actor location. I swear they've made this search box worse over time.
There. And then this goes into here.
Yeah.
I think that was the right one. Get actor location into the top and get player location into the bottom. Okay, so I might need to flip these. There. And then there's the dot product.
All right. And so now we know that essentially we want to track this as it decreases from 1. And this is something where we have the opportunity to, where we set this threshold, is going to kind of give us our ability to finesse when it turns off. So, if you essentially have it to 0, it will only turn off when it crosses past the point of perpendicularity. So it will turn off when it's beside the character.
Yeah. So just this, right?
Yep, and then we can play with it and see how we can finesse it, essentially.
Wait. So this would be greater than 0. Well, the dot product is greater than, less than or equal to.
Yeah. I'd probably just give it like a minor epsilon.
Why?
It floats are fucky. So for that comparison, I just give it like a 0.05.
Oh, okay, yeah. So like it would be greater than or equal to.
Yep.
Greater than or equal to 0.05.
Yeah, just as a arbitrary epsilon, just because floats are fucky.
That's still not fun.
But now we can tweak this because, as you can see, it's essentially getting to that point of being beside. You can see that sharp turn, and then it turns off. So we can essentially adjust our threshold, so that way we don't get that sharp turn.
Okay, and that would be up or down.
So
Feel like up,
that's going to
maybe?
be, yeah. That's, we might need to print these values.
Yeah, might need to print them. Might also so weird. Okay. Well, why don't we do this? Because we just want to know right now where it turns. Like right now, I'm more curious about where it turns off, right?
Right. And something else you can do is just use that dot product to lerp your homing acceleration magnitude.
One sec.
Now the
Give me.
important thing is whether it turns itself back on.
We don't want it to turn it off at all. Oh, right. No, it can't turn itself back on. Because it's default to on. Nothing's turning it on. There's no code turning it on. There's only code turning it off.
So I'm not quite sure what you mean.
One sec. Wait, did I do something fucky? Hit the spawn actor.
to. I'm not entirely sure why you're setting the on hit effect. To be honest, I'm not sure what that event has to do with the homing right now.
It has nothing to do with it.
Okay. I am no longer confused then.
I was just cleaning up a weird variable that I had. Let's make sure this still works. Okay, yeah, everything seems to be still working.
Also, there's a chance that we have the one of the direction vectors backwards. Because if
yeah,
they're
that's true.
because if rather than parallel, if they're facing opposite directions, it's -1. So it'd be backwards in that minus node rather than the dot product.
Oh, okay. Yeah, it's probably this. It was that. Yay!
Yeah, and then now this should give us the ability to finesse it a bit better.
I'm fine with this for now. This actually just works. This is kind of what I wanted anyways. For the most part. I want to, before I finesse it, I want to actually have a gameplay loop.
Yeah, that's fair.
Okay. Let's see how it feels when I go and actually attack something. Well, I got my ass handed to me there. Fucking sniper from across the map there. Alright. Well, we got most of this working. Now I just need to figure out. That's interesting.
Yeah.
That's a bug.
You can also have a check based on just simply the distance from the player for whether or not it homes.
I was gonna do that. But this is weird. Because it should be firing directly at the player, and it's not. Now it is. Okay, so that's just the rotation bug, I think. Yeah, that's just the rotation bug. Okay, I can work with that.
Alrighty. And then yeah, you're in a good place to do any further anticipation if you want. Dear Lord, you're using Trello. That you might as well be writing Jira tickets right now.
No, I'm just using it very basically. No Jira required. Fuck Jira.
You're supposed to be using Hack and Plan because it's just Jira marketed to game devs.
I think I've seen Hack and Plan.
Yeah, it's honestly just generic Kanban style planning, but
With more
sold to
images.
game devs. Yeah.
Yeah.
Yeah. Night mode, sexier theme.
Yeah, that was pretty much like tasks, points, burn down charts.
Yeah.
Just like, this sounds like Jira, and it's expensive.
Yeah. And imagine using that when you could just use org mode.
Org mode?
Emacs stuff, don't worry about it.
Oh. No, Trello works because it just gives me where I'm at, what I did.
I think the most effectively I've ever used Trello was planning Christmas shopping.
Interesting.
Yeah. Otherwise, I am very much a pencil and paper person.
I can understand that. All right.
Or the other, yeah.
I am going to call it a night.
Yeah, I
because
should
I have to
do-
go chat with a friend about something.
Alrighty, yeah.
But sorry.
No, I was just gonna say I should probably get out of here since I have like some early mornings with someone in
Yeah.
Greece. So
Yeah, you might want to do that. Well, thank you. Thank you
Yeah.
for all the help, man.
Oh yeah, no problem. This is fun stuff. So
Yay. All right,
Yeah,
I will catch
cheers.
you later. Bye.
Yep. Bye.
Proton, thank you for the help earlier as well. And it was good chatting with you. Thank you to everybody who showed up. Thank you for everybody who followed, like Proton. Well, thank you for Proton for the follow. And thank you for everybody who lurked and chatted and everything. You were all awesome. And I will catch you maybe tomorrow, maybe Wednesday. Probably tomorrow, knowing me though. Anyways, I will see you guys later. And bye-bye.